If you've seen my videos before, you know I've converted this 3040 CNC frame into a fairly respectable little machine. It's not perfect, but I knew that going in. I knew there'd be upgrades that I would have to do to it to get it where I wanted it to be, and ultimately I knew I'd have to replace it because it would never be big enough. So I was doing some parts the other day and had a little mishap, so I thought it was about time to really get going down the upgrade path. And as I started going down that path, thinking what I needed to do, I'd like to get new software. Chili Pepper's great for what it is. Well, I don't even know if it's technically out of beta or not. I know John's working on it all the time, constantly adding new stuff to it, but at the end of the day, it's going to be a browser-based G-code sender, essentially. And it's never going to match in performance something like Mach 3 or Linux CNC. So for the hobbyist, it's great, but I would like to be somewhere between a hobbyist and a home machine shop guy. So I think I've decided I'm going to have to upgrade to something, probably Mach 3 or Mach 4. Not 100% decided on that, but once I realized I was going to upgrade the software, I realized I would have to get a new control board that would work with it. And a new control board that doesn't have the integrated drivers in it like the Tiny G does, I would need to get drivers. And once I get into all of that, I mean, you're looking at several $100s to do that upgrade. So I thought, well, maybe I'd just get some servos, because ClearPath makes a great little servo motor that uses step and direction signals. It's just perfect for this kind of thing. But again, I'd have to upgrade more parts to upgrade that, and on and on and on it went, until finally I realized, you know, maybe upgrading this machine the way I had intended to isn't really the best plan. So today I would like to introduce you to my new project, which is right over there. So here it is, the platform for a new, completely custom-built CNC machine. I don't have the design completely finalized yet, but I think I'm pretty close and I'm about ready to get started. I'm just doing some of the basic work. As you can see, I've already got some linear bearings and some ball screws for the X and Y axis, and I thought today we would go through the process of starting to put this stuff together. First thing I want to do is get the Y-axis linear bearings mounted. I want to make sure they're straight, so I've got two spacers and a ground steel bar I can use to check for straightness. The dial indicator showed that I was off by a few thousandths, so I checked it with a straight edge and some feeler gauges. The flattest thing I had in the shop was the surface plate, so I put it on its edge and used some clamps to get the rail to be as straight as possible. I started with one side and just tightened the bolts down as I went. Once I got that rail straight, I bolted the X-axis plate to the rails so I could align the second rail with the first. I just had this piece machined out of a scrap piece they had up at work.
the bearings secured on the first rail, I could align the second with the bolt holes in the plate. Right now the rail's just resting on the table. I want to get it aligned before I mark out my mounting holes. Check the spacing of the first rail, and then unmove the second rail to match. With the X-axis plate holding the rail in the exact location, I can mark my first hole for drilling. I borrowed this awesome mag-based drill from work, but since the top is aluminum and non-magnetic, I clamped a piece of steel to the top for the magnet to rest on. Now I can line up my center drill to the mark I made earlier. With the center drilled, I can switch to the twist drill. I tapped the hole by hand, using the mag drill to make sure it was straight. Now I can install the first bolt that will hold the rail in place while I align it. Now I need to get the X-axis perpendicular to the Y-axis, so I borrowed this large precision ground angle plate from work. I can rest it against the Y-axis rail, checking with the feeler gauge to make sure it's aligned. At this point I've already done this once and marked, drilled, and tapped all my bolt holes, so I can install the bolts. Using this technique, I can get the assembly to slide smoothly without having to measure precisely. I just let the rail tell me where it wants to be. With all the bolts installed and tightened, I can install the little plastic covers over the holes. Now the important part. I have to align the X rail so that it's perpendicular to the Y rail. If it's not, any cuts made on this machine won't be straight. I use the precision angle block again, and this time use the ground shank of 2 drills which fit nicely in the groove of the rail and are just the right size to space the rail from the angle plate. The first rail bolted down tightly, perpendicular to the y-axis, I can install the second X rail loosely so I can align it later. This time though, all the bolt holes were drilled and tapped for me, which is much nicer. With the rail in place, I can mount the first ball screw. Just like mounting the rails, I've attached the ball screw to the slide, and I'm kind of let it show me where it wants to be mounted. Rather than drill holes and try to force the ball screw to fit those holes, I just take the holes off of where the ball screw wants to naturally sit, and that way I don't get any sort of binding. The X-axis ball screw was a bit too long for the salvaged X-axis plate, so I machined up a couple of tabs which I can bolt onto the plate to give a little extra length. The ball screw doesn't produce much force up and down, so I'm pretty confident I won't have much trouble with this solution. With the tabs mounted, I can align the second axis rail using the work table, using spacers to provide clearance for the ball screw. I use a square to get the table at least close to being square, but it's not critical. With that done, I follow the same procedure as before and use the bearings to align the rail for me, tightening bolts as I go. With the rail taken care of, I can install the ball screw just as before. And that's the XY assembly done. If you like this project, make sure to subscribe because there's going to be quite a few more videos as I figure this whole thing out. See you next time.